is Wafi, and today I'll be presenting our C programming assignment. And the project itself is called the Automatic Railway Gate Crossing System. Basically, you know how usually when it comes to railway crossings, they're usually operated by human operators, and when that happens, there are some, and they're usually posted at the guards for quite a while, maybe a whole day and whatnot, so they can be tired, and they might not even notice that a train can pass by and accidents can occur. So to counteract that, we decided to develop the system. The system mainly uses a servo motor, IR sensors, and an Arduino Uno connected to a breadboard.
Okay, so now I'm going to talk about our objective of our project. So our project is to design and implement an automatic railway crossing gate system using an Arduino Uno. And second, to utilize the IR sensor, IR sensor, for real-time train detection for both approaching and exit sites for the crossing. And third, to control the servo motor, as you can see at there, the servo motor as the gate mechanism that open and close the based on the sensor input. And the last, to write the C programming that integrates sensor reading with the motor control logic.
I will explain about the circuit deployment of the automatic railway crossing gate system. So the system using Arduino Uno as the main controller that can control all the other output devices. The model used for this Arduino Uno is CH340. Okay, so a breadboard is used to connect all the components neatly and distribute the power from the Arduino Uno, which is 5 watt, and without the need for the soldering. Okay, as you can see, 2 IR sensors are used to detect the presence of the train. For the first IR sensor, connected to the D2 pin, and the second IR sensor is connected to the D3 pin of the Arduino. So the first IR sensor, when it detects the train approaching it, it will send the signal to the Arduino, and the Arduino will send signals to the servo module, and the servo module will closing the gate. For the second IR sensor, when the train is approaching to it, we will send the signal again to the Arduino system, and the Arduino will send the signals to the servo module again to open the gate. So the servo module acts as the railway gate by lowering the barrier when the train is detected and raising it again after the train leaves. The LED is also used as a warning light to let drivers and pedestrians know that the crossing gate is closed, while the buzzer provides a sound alert for extra safety. Okay. 1K ohm resistor is also used to protect the LED from excess current flowing through it, to protect it.
Hello everyone. Today I will be explaining our code for the automated railway crossing system. First off, I'll be introducing our inputs and outputs. The two inputs we have is sensor 1, sensor 2, which are connected to an IR sensor by pin 2 and pin 3 respectively. Moving on to our outputs, we have LED, buzzer, and servo pin. The servo pin is used for our gate. Moving on to the main code, void setup. We initialize the inputs and outputs of our system. Sensor 1, sensor 2 are obviously our inputs, and
LED, buzzer, and servo pins are our outputs. And the gate initially needs to be open, so we make sure that it's at 90 degrees, which is open. Moving on to void loop, we have an if condition for the LEDs to check if the sensor detects any movement, and the moment it does, it will print out train is approaching, and it will activate our warning system, which basically flashes the LED light and the buzzer 5 times repetitively to warn drivers and whatnot. And afterwards, it will close the gate using our function that we developed, and leave the LED on, as to indicate that a train is currently crossing. Afterwards, we use a while loop for sensor tool, so that the gate remains closed. Because if we don't have the while loop here, it will just continue on to open gate without having without the second gate having any. I mean, without letting the train completely pass by. So yeah, the while loop's just there to maintain the gate, make sure the gate is maintained closed, and afterwards it will print out trains passed, delay for 2 seconds, and the gate will open using our function. And obviously the LED and the buzzer are turned off afterwards. Moving on to our two functions, we have close gate and open gate. Close gate, these two functions are just used to smoothly change servo position from 90 degrees to 0 degrees to close and open the gate. And that will be all. Thank you very much.
First, I will explain the main components used in this project. The system consists of an Arduino Uno, two infrared sensors, one in the front, one in the back, a servo motor, an LED, and a buzzer. The IR sensors are used to detect the presence of a train, when the servo motor acts as the railway crossing gate. As you can see here, it's a gate. And finally, the LED and buzzers provide visual and audio warnings to road users. Next, I will explain how the system works. When a train approaches the railway crossing, it is detected by the first IR sensor. The sensor sends a signal to the Arduino, which processes the input and activates the warning system. The warning system is basically the red LED, which turns on, and the buzzer also sounds synchronously. Finally, the servo motor will lower the gate to block the road traffic. As the train passes through the crossing area, the gate will remain closed to ensure safety. When the train reaches the second IR sensor, which is over here, the Arduino recognizes that the train has completely passed the crossing, and the buzzer stops, the LED turns off, and the servo motor raises the gate to allow the vehicle to pass again. Now I will demonstrate the operation of the system. When I place an object in front of the IR sensor, the gate automatically lowers and the warning indicators are activated. As you can see, the LED is on and the buzzer buzzed, finding the gate closes. And after moving the object to the second IR sensor, the system detects that the train has left the crossing and the gate automatically returns to its original position. Finally, this project demonstrates how automation can improve railway crossing safety by reducing human error, providing timely warnings, and control traffic efficiently. Thank you.